evaluating the reliability of a 2-point Likert scale questionnaire or a survey in SPSS using a Cronbach's alpha equation. The test will measure the internal consistency of items and test whether the questionnaire or a survey, if repeated on different dates or times with the same group of participants, will produce or generate similar outcome or responses from the participant. And the way to evaluate the reliability is to do a reliability test using the alpha equation, which is equal to K divided by K minus 1. K stands for the total number of items or questions, multiplied by 1 minus the sum of the variance for each individual item or question, divided by the variance for the total score. Here in this SPSS data view, I had placed data extracted from the responses of 20 participants in a questionnaire answering 20 questions or items, giving their opinion on a specific question, and their response was scored based on the 2-point Likert scale. 1 stands for agree and 0 stands for disagree. So these data are dichotomous categorical, as there are only 2 options, either agree or disagree. And to evaluate the questionnaire and to determine whether the survey or the questionnaire as a whole is reliable, then we will do the reliability test based on the Cronbach's alpha equation. The first step is to calculate the total score obtained from the participant giving their opinion on each specific questions or item, i.e. combining the scores achieved or recorded by each individual participant. To do that is first to click on transform, then click on compute variable. In the compute variable, I'm going to generate a target variable, call it total score, total score, and to add and combine the values for the scores achieved by each individual participant, we're going to use the sum command. And the way to do that is to click on the function group, scroll down to statistical words here, click on statistical, then select the sum command and drag it into the numeric expression. In the numeric expression, we're going to add the variable for the Q number 1 to Q number 20 in between the bracket, separated by a comma. So we're going to insert the first item or variable or question, followed by comma for the second one, and then for the third. Every time insert a variable, need to separate it by a comma from the next item or variable. Question number 10, and then 11, and then 12, and then 13, and then 14, and then 15, 16, towards the last one, which is Q20. So we have inserted all the items or variables between the bracket, and if we click on OK, a target variable is generated here on the right hand side for the total scores recorded by each participant. Going to do a few editing on this target variable, going to reduce the width of the column into 4, and I'm going to make the data centered, and I'm going to keep the decimal to 0. So we have calculated the total score. The next step is to transpose these data, and the way to do that is to click on data, scroll down to transpose, and in the transpose I'm going to move the ID into the name variable, and I'm going to select all the variables and drag them into the variables box and click on OK. The data is transposed in a way that now we have the questions or the items in rows. I'm going to do few editing here, since we're going to be interested in just using 2 decimals, so we make all the rest of the values 0 decimals, and we're going to align the scores into the center, select and then drag, and I'm going to decrease the column width into 4, keep it at 4 for all the target variables. And we're going to, since we have here a dichotomous, we are going to measure the data based on nominal. Copy and make it nominal, and going to change the label here from K1 into S1. And the way to do that is to select the column here and then Control F for find, and click on the replace and then type K underscore, and then replace that with capital S4. And if you click on replace all and then close, and we can see here all the label has been changed to S1 to S20, from S1 to S20. So now we have calculated the total score, transpose the data, edit the data. The next step is to calculate the variance for all the items or the questions, and also to include the variance for the total score. And the way to do that is to click on transform, compute variable, and then I'm going to type here a variance for the new target variable to generate, and I'm going to select from the function group under statistical the variance, dragging the variance into the numeric expression. So we're going to calculate the variance for all the items and for the total score. Again, we need to insert these variables in between the brackets followed by the comma for S1, and then insert the second comma, and then comma in between the variables, otherwise the command will not be executed, comma, and then S4, comma, S5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, until all the variables are included in the brackets. Last one here. So now we have inserted all the variables from S1 to S20 in between the bracket, and if we click on OK, a new target variable is generated that is called variance. And as we can see here, we have the variance for each individual item or question and the variance for the total score. I'm going to do a little bit of editing into the variance variable. I'm going to align it into the center, and I'm going to reduce that into 4, and I'm going to keep it as a scale for the variance, and I'm going to do no more changes here. So now we had calculated the variance for each individual items and the variance for the total score. So following this formula, now we had most of the values for components or part of this equation already determined. We need to add up all the variance for all items in SPSS, and the way to do that first is to click on the variance for the total score, and I'm going to remove that and place that in this formula here. So we have now the variance for the total score in the equation. The next step is to add all these variance together from item number 1 to item number 20, and the way to do that is to click on Analyze, scroll down to Descriptive, select Frequencies, select Statistics, click on Sum, click on Continue, then select the variance as we are going to calculate and add all the value within this variance, and then click on OK. A small table here is generated showing the sum for the variance, which is 4.82. So we're going to use this formula and type here 4.82. So we have now the value for the sum of the items variance, or the variance for all the items. So we're nearly now ready to calculate the alpha value. The k value here is the total number of questions, which is, in this case, is 20 divided by k minus 1, which is equal to 19. So we are ready now to work out the value, and I'm going to use a calculator for this purpose. So if I type calculator and then click on calculator here, and I'm going to first of all find the value for the scores here between these two brackets. So I'm going to divide the upper part by the lower part and subtract that from 1. So 1 minus 4.82 divided by 45.73 equal 0.89. I'm going to multiply that by 20, and then divide that by 19, which will give us a value of 0.94. So this value here means that this questionnaire or this survey is 94% reliable. So it has high reliability value. Thus, this questionnaire is excellent in reliability. From this reference table shows the Cronbach's alpha value and the reliability level. If the alpha value is equal to 0.9 or greater, then the reliability is excellent. If a questionnaire have a alpha value of a range between 0.8 and 0.89, then the reliability is good. Questionnaire will have an acceptable reliability when the range for alpha is between 0.7 and 0.79, and a survey will be questionable in reliability if the value is between 0.6 and 0.69 for alpha, and it will be a poor questionnaire if the value of alpha is between 0.5 and 0.59, and a questionnaire will be unreliable, unacceptable if the value for alpha is less than 0.5. So this is the way to calculate and determine the Cronbach's alpha for a questionnaire that have a dichotomous data in it, binary data, 2-point Likert scale, 2 options for the participant to choose from, either agreeing or disagreeing. This is the way to do it in SPSS.